Welcome back to my channel Chemistry Drive. Students, how are you? Hope you are doing well. Yesterday we read about nomenclature of haloalkanes and haloarenes. But now one topic has been left, that is polyhalogen compounds. It is very simple topic and you are familiar with most of the terms like freon gas and the chlorofluorocarbons, the chloroforms. So these are some of the things that we are going to discuss in this chapter, students. So let's start. This is one of the most important topic of your haloalkanes, because sometimes in your exams its uses may come, its preparation may come, so you must be familiar with all these things. So let us start. So what are polyhalogen compounds? So actually polyhalogen compounds are those compounds which are made up of one or more halogen atoms. For example, we can see CFCl3, that is trichloro. It has 3 chlorine atoms and 1 fluorine atoms. That is trichloro, monofluoro, methane, and then dichloromethane. So these are some of the examples of polyhalogen compounds. In polyhalogen compounds, let us take our first example, that is dichloromethane. So dichloromethane, how it is prepared? Methane is reacted with chlorine in the presence of sunlight. So during sunlight, 2 atoms of it is replaced by the chlorine atoms. So this reaction occurs in the presence of sunlight. 1 HCl is removed. Again it will react with chlorine atom in the presence of sunlight. Again 1 HCl molecule will be removed and you are getting dichloromethane. So this is how dichloromethane is prepared in diffused sunlight. So what are the properties of dichloromethane? It is colorless, sweet smelling, and it is volatile. Volatile means it is vaporized easily. It turns into vapor form easily. It has low boiling point, low inflammability, and it is insoluble in water. It is not so much soluble in water. Uses of dichloromethane: it is widely used as a paint remover. You commonly use it at your homes. Then it is also used as a solvent. Solvent, that is as a cleaning agent in chemical industries, textiles and electronics. The next one is, it is also used as a process solvent in the manufacture of different types of drugs and medicines. So this is all about dichloromethane. The next one is trichloromethane. Students, trichloromethane, it is also prepared by the reaction of methane with chlorine, as I have told you before also. And in this way we have got trichloromethane. Actually the common name of trichloromethane is chloroform. You are much familiar with this term. Properties of trichloromethane: it's a sweet smelling liquid. It's a you can put it on your handkerchief and you can go into the unconscious level. So it's very dangerous, students, also for that. Chloroform is slowly oxidized by air. So what happens when chloroform, it reacts with oxygen, it in the presence of light, it gets converted into a highly toxic gas that is known as phosgene. So to avoid this oxidation, chloroform is always stored in dark colored bottles so that the reaction does not take place in the presence of light, and it is filled to the brim. It is filled up to the level in order to avoid the reaction with air. And further, the bottles, they are also filled with small amount of ethyl alcohol. What happens when phosgene reacts with ethyl alcohol? It forms diethyl carbonate, and that diethyl carbonate is also non-toxic. It is now no more toxic. So this is how we change the phosgene gas into a non-toxic form, that is diethyl carbonate. Our next polyhalogen compound is iodoform. Iodoform, that is any compound that contains carbonyl group, that is CH3CO, or, and you know CH3CO group is being contained in ketones and aldehydes. So any compound having CH3CO group or CH3CHOH, that is secondary alkyl group, they can react with iodine and aqueous NaOH. They gives yellow precipitate of iodoform. So remember the structure of chloroform and iodoform. In chloroform, you have 3 chlorine atoms attached with 1 carbon atom. whereas in iodoform you have 3 iodine atoms attached with 1 carbon atoms. So this is the difference between the two. Iodoform, it was used earlier as an antiseptic, but nowadays due to the liberation of free iodine gas, due to its objectionable smell, people just don't like it, so it has been replaced by other antiseptic liquids. So iodoform is now no more in use as an antiseptic. The next one is tetrachloromethane. Tetra, as the name suggests, it has 4 chlorine atoms with it. Now how it is prepared? In the presence of carbon disulfide, chlorine atom and anhydrous aluminium chloride. Anhydrous means that is, it does not contain any moisture. It forms sulfur monochloride, so and carbon tetrachloride. Now again this sulfur monochloride can react with remaining carbon disulfide to form carbon tetrachloride. So students, this is how you can prepare the carbon tetrachloride. Now when heated at steam and at temperature of near about 773 Kelvin, it produces harmful gas phosgene. We have studied it just now. Uses of tetrachloromethane is that it is used as a solvent for many oils and fats. It is used as a refrigerant and a dry cleaning agent, and it is used as a fire extinguisher also. Now a most important topic is freons. You know about freons? Freon is the gas that is being used in the fridge for the cooling effect. So it is prepared mainly by the Schwarz reaction. It is prepared by reacting carbon tetrachloride with antimony trichloride, and heating we get freons, that is difluorocarbon methane. So we can say that the chlorofluorocarbons mainly we talk in our daily lives, they are nothing but freons. So freons, they are extremely stable, unreactive, non-toxic, non-corrosive and easily liquefiable gases. So due to its properties, it is used in refrigerators. And the most important thing that is being done by freon is the depletion of ozone layer. As you know, the ozone layer, it prevents us from the harmful ultraviolet rays, but due to the use of freons in our fridges and refrigerators, there has been created a hole that is known as ozone hole that has been seen over the Antarctica region. So be cautious. I hope that our future scientists will try to make another gas or another substituent for freons so that it can be used in refrigerator, because refrigerators has become for a great use in our life. So students, what are the uses of freons? They are used in aerosol propellants, refrigeration and air conditioning purposes. So we should try, our new scientists should try to use the substituent of these. Best of luck for this. The next one is dichloro diphenyl trichloroethane. So what it is? If you look at the structure, it has 2 carbon atoms, that is why the name ethane. So dichlorodiphenyl means one chlorophenyl group, another chlorophenyl group and 3 chlorine atoms attached with another carbon atom. So we can say that its structure is dichloro diphenyl trichloroethane. I hope it's clear to you. So you should try to practice its structure. It's very easy. Properties of dichlorodiphenyl trichloroethane, that is DDT. It is a white powder and it is insoluble in water. It's a highly stable compound and it is fat soluble also. As you all know that DDT is used as an insecticide in agricultural field, but nowadays it has been banned. So students, these are all about polyhalogen compounds. I hope you liked my video. I have tried to cover all the important polyhalogen compounds in a very short duration. So I hope it is up to the brief, up to the level that will come in your board exams. Thank you so much for watching my video.